Hi, I'm Sarah. Are you a senior high school student struggling with integrals? Do you feel like calculus is just a bunch of squiggly lines and weird symbols? Well, you're not alone. But don't worry, I got you. In this session, I'll break down integrals in a way that actually makes sense. By the end, you'll not only understand them, but also be able to solve the problems with confidence. Alright, let's dive in. Think of integration as adding up tiny pieces to get a whole. Imagine you're filling up a swimming pool. Every drop of water counts. That's what an integral does. It sums up small parts to find the total. We have two types of integrals: definite and indefinite integrals. When integrating a power of x, we use the power rule. This means we increase the exponent by 1, then divide by that new exponent. So, the integral of x raised to the power of n with respect to x is x raised to the power of n plus 1 divided by n plus 1 plus c. If there's a constant multiplied by x, we keep that constant outside and integrate normally. When integrating just a constant, we multiply it by x. And for expressions like ax plus b, we still use that power rule, but divide by the coefficient of x to adjust the result. A definite integral gives the total accumulation of a function over a specific interval from a to b. Unlike an indefinite integral, which has a constant c, a definite integral gives an exact value, often representing the area of a curve. To solve it, we first find the antiderivative of the function, which we call f of x. Then, we substitute the upper limit b into the f of x and do the same for the lower limit a. Finally, we subtract the two, so the result is f of b minus f of a. Now let's try solving these two problems. Let's start with the indefinite integral. This type of integral finds the general antiderivative of a function, meaning it includes a constant of integration c. Our example is the integral of 3x squared plus 2x plus 5 dx. Step 1. Integrate each term separately. First, the integral of 3x squared dx. By increasing the exponent by 1, then divide by the new exponent, this gives us x squared, x cubed. Second, the integral of 2x dx. Again, increase the exponent and divide. This results in x squared. Lastly, the integral of 5 dx. Since 5 is a constant, integrating it simply gives 5x. Step 2. Combine all terms. By adding them together, we get the integral of 3x squared plus 2x plus 5 dx is equal to x cubed plus 2 squared plus 5x plus c. So that is our final answer. Since it's indefinite, we include the constant c. Now let's move to the definite integrals. Unlike indefinite integrals, definite integrals evaluate the function over a given interval, giving a numerical result. Our example is integral from 1 to 3 of 2x plus 1 dx. So, step 1, find the antiderivative. The integral of 2x plus 1 dx is equal to x squared plus x plus c. Step 2, apply the limits. First, substitute x is equal to 3, which is 3 squared plus 3 is equal to 9 plus 3 is equal to 12. Then substitute x is equal to 1, which is 1 squared plus 1 is equal to 1 plus 1 is equal to 2. Step 3, subtract the values. So 12 minus 2 is equal to 10, which means that our final answer is x squared plus x plus 10. Now that you know how to solve basic integrals, let's find out their applications. Here are some examples. A physicist who knows the velocity of a particle might use integration to determine its position at a given time. And a biologist studying bacteria growth can integrate the rate of increase to predict the future population size. and many more. And that is all for today. Thank you for watching.